Just wanted to take a moment to clarify this question because I'm not sure that doing this written out this way is the best way. So if you've kind of walked through this, you kind of know what we're talking about. But I wanted to show this in terms of a tree diagram so you get a better understanding. So you notice that like the Denver Broncos, and certainly this isn't a really realistic application, but it just gives you an idea. And so if there's going to be a win or a loss, we really have to tell if the game's going to be at home or away first. So we can set up our tree diagram by saying home and away. And then after that, we can set up the tree diagram as win or we'll say not win. And then win or not win. So we really want to look at what it's going to be to win. Now, the numbers that go on the tree diagram is you just have to ask yourself, well, what's the probability of it being a home game? And so there's 70% chance, 70% of the home games are left, so there's a 0.7 chance of it being a home game, so 0.7 can go there. There's a 30% chance of it being away. And if it's a home game, that there's an 80% chance of winning and a 20% chance of not winning. If it's an away game, they have a 60% chance of winning and a 40% chance of not winning. And so you can actually look at all of the different outcomes, winning at home, not winning at home, by multiplying 0.7 by 0.8, we end up getting 0.56 or 56%. 0.7 by 0.2, we get 0.14%. 0.3 by 0.6, we get 18%. And 0.3 by 0.4, we get 12%. And so if you ask the question, what's the probability of winning, we can now see that it's this plus this. And so there's actually the total probability of winning is 74%, 0.74, which is 74%. And you can see that, like, in the other one, it's going to be helpful for us to talk about multiple cases in the next unit. But a tree diagram in this case, just like the Mr. Jordan question, can illustrate it without being too complicated, just kind of by keeping two straight sets. And so this kind of is a visual way, just like Venn diagrams are a visual way to look at mutually exclusive, non-mutually exclusive. This is a really good way to look at independent and dependent sets.